Welcome to Abstracts, a Microsoft research podcast that puts the spotlight on world-class research in brief. I'm Dr. Gretchen Huizenga. In this series, members of the research community at Microsoft give us a quick snapshot or a podcast abstract of their new and noteworthy papers. I'm here today with Dr. Arindam Mitra, a senior researcher at Microsoft Research and the lead researcher for Microsoft's Orca project. Dr. Mitra is co-author of a paper called AgentInstruct, Toward Generative Teaching with Agentic Flows. Arindam, it's a pleasure to have you on Abstracts today.
Thank you, Gretchen.
So let's start with a brief overview of your paper. What problem does your research address, and why does it matter?
So the post-training phase is very important for language models. You can really improve the model a lot by creating high-quality synthetic data. The problem is, however, though, high-quality synthetic data creation requires lots of human effort and expertise. The problem that you're trying to tackle is how do you reduce human effort? How can you create high-quality data with really low amount of human effort? When you have a language model, and let's say you want to apply it somewhere, you might have trained a generic model before, which could be small or big, doesn't matter. Mm-hmm. After that, you can specialize it on the domain that you're looking for. And when you want to do that, to make it really fast, this particular process, it's best if you go for synthetic data. If you have a way to actually generate very high quality synthetic data, you can fast track this part of specialization process, not only single model. So this year, you're going to see a lot more multi-agent models. And when you are trying to build these multi-agent models, you're fearing like, okay, it might increase the cost too much, the latency too much. So it's also very much important that you have a multi-agent system and you can sort of replace some of those agents with specialized small models. And when you're trying to address these goals, you want this process to be something which you know works fast. So that's why we're trying to make sure we have a very good way to create synthetic data for your specific need.
No research exists in a vacuum, and most of it fills some kind of a gap. So tell us what's already been done in this field and how this work is building on it.
So previously, actually, we have seen that in post-training, the more data you have, the better the performance goes for the model you're training. So what we wanted to test is how much we can scale and what happens if we scale a lot. But we didn't have the tools for it. So the other approaches people previously used was you had a small set of data, and how do we expand this data set into much larger and larger amount of data? That's where people are mostly focusing. But it's not that easy to create that initial seed set. You need to be very expert. The way that we're doing is actually rather you define what you want to create. Like, okay, you want to create tool use data. So you say, okay, I have a bunch of tools and I am looking for data in these scenarios where someone can just come give me a description and then maybe that person will interact with the AI to figure out how to get the job done. It's not a one-step thing. And maybe you also have a setting where it's more like an app developer. You have a bunch of APIs in your phone. You just want to figure out which one is best for the user request, which came through voice command. So different scenarios could be there. So what we're saying, okay, we are not going through the method where you have to come up with your initial own seed data. Then we expand. It is more like you define what you want to do. It's much more abstract. And then we are sort of automating the effort of data creation. So this setting actually of synthetic data creation, we are referring it as generative teaching, and that's where we're sort of differing. So previously it was more like expansion, and now we are trying from specification to the data that you need.
Gotcha. Well, talk a little bit more about your methodology and how you went about conducting this research.
So first of all, what we are proposing actually is a multi-agent solution. So you start with first describing what you really need. So you describe in detail, like I need data for this specific skill or this specific scenario. Then what we do is like, okay, you have some unstructured data or raw data like text documents or code files that you gather from a web with permissive license or use something that you own. We don't care much about what the content is really. So it's more like we got some random stuff, some random content, and then we'll guide you how to convert this random something which is not meaningful for you into something which is meaningful for your data creation. For example, like if you're creating data to teach how to use APIs, you might think about you need lots of APIs and how do you get this API? So what we are saying is like you can take something like code And we'll have agents which will convert these raw code files into a list of APIs, which is more like a library. So we create automatically this input that is very meaningful for data creation. And then once we have that, we have basically the seed instruction creation step based on your specification, like where you want to create data for. So you have all these different scenarios, and we have multiple agents creating data for different scenarios. And then the last step is actually what we call refinement step. So it's more like whatever data you created, we'll go through them and we'll make them better and better, improve the quality, improve the complexity, improve the trickiness. We'll teach when not to answer, etc., etc. So we'll make sure we cover the whole space. So by changing the stochastic seed, we are trying to cover the entire possible data space.
Right.
So that's the key thing. The way we sort of conducted this research is actually we defined 17 skills. Skills meaning reading comprehension, tool use, text modification, content creation, RAG. We have like list of 17 skills, conversation, and then we created one multi-agent flow for each of the skills, and we generate data. So one key thing I want to highlight is like this work compared to other work, it was not benchmark driven. We want to teach a skill. We don't care which benchmarks we're trying to evaluate it on. So we define the skill, like tool use means this to us, reading comprehension means this to us, text modification means this to us, and then we sort of generate the data to teach everything for that skill. And then what we did, we created actually 22 million instructions, and we had previously in Orca series, we had 3 million around instructions. So the 25 million is what we sort of have at the end, and that's where we actually trained a Mistral model as of now. And we want to measure like how much we improved the Mistral model by this post-training.
Moving from methods to findings, I always look forward to the part of the research paper that finishes the sentence. And what we found was, so give us a quick overview of your results. What did you find?
Yes, so the results were actually very exciting for us. So Mr. 7B was our main sort of baseline because that's where we're trying to showcase like how much improvement we're getting. On the other side, we have like frontiers models, ChatGPT, GPT-4. We want to also measure how far we are from those frontier models. So that's sort of our evaluation setup. So on average, actually, we got like 20% performance gain over the Mistral. And we evaluated that across 14 benchmarks that test reasoning, content creation, instruction following, format following, etc. But what was more important to us was to do a skill-specific evaluation because we are trying to teach certain skills, and we had like 17 skills as you mentioned earlier. So, for example, like if you're focusing on reading comprehension as a skill, we took LSAT, SAT, and DROP and many other benchmarks. So we created a collection of reading comprehension specific benchmark. And there we are observing like 20% improvement over Mistral. And what it means, like we're actually achieving GPT-4 level performance. Similarly, if I'm focusing on math skill, there are many datasets which test like elementary math, high school math, college level math. And we improved actually across all these different levels of math. So we see from 40% to 150% of improvement on different benchmarks of math. So it was more like what we wanted to see. We're not optimizing for a particular benchmark. We wanted to optimize the skill, and that's what you're observing. So you're observing improvement in math across all these levels, from elementary to high school to college to middle school, etc. Everything. The same goes for RAG as well. We are observing on RAG skill 92% around improvement over Mistral. The format following numbers are pretty interesting to us. So format following is very important for SLMs. We want to make these models practical. We want to make sure that they follow the format so we can pass the result. And we were able to take Mistral beyond Gemini Pro. So that was a very strong performance from the post-training that we did. For summarization, actually, we were able to reduce the hallucination rate by 31% while attaining the GPT-4 level quality. So overall, all these results were sort of highlighting that the methodology that we have, which we're calling AgentInstruct, is very promising.
I think it's important to get practical and talk about real-world impact. So tell us who you think this research will benefit most and why.
Yeah. So again, the model builders will sort of find it most beneficial. So the significance of our work actually lies in the way we are trying to revolutionize the language model development through scalable, low effort synthetic creation. And the scalable and low effort is sort of the key thing. Like we have shown that we can create very high quality data. That's what the numbers are telling us. We want to mention that this is very scalable and low effort, and that's what we think might help the most for model builders.
So, Arindam, let's borrow a phrase from the machine learning lexicon and go for a little one-shot learning here. If you had to boil down why your work is important, what's the one thing you want our listeners to take away from this research?
The key takeaway would be like the AgentInstruct method enables the generation of vast, diverse, and high quality synthetic data with very minimal human input. So that's one thing I would like to remember from this paper.
So, as we close, talk briefly about the limitations that you encountered in this project and directions for future research. What are the outstanding challenges in this field, and what's on your research agenda to overcome them?
Yes, so we're exploring further automation, but apart from making this data creation more automated and less human involvement needed, we're trying to focus on two other aspects. One is automated model debugging, and another is automated model repairing. So now that we have the ability to generate data for a particular skill, let's say math, for model debugging, what we need is basically a error handler. Like if something we can plug in, which takes the question and the answer coming from a defined model and verifies if the answer is correct or not. So that's the part we're working on right now, figuring out this error handler. And the second aspect is repairing. So once we have the error, we figured out, okay, this is where the model is struggling. How can we give feedback, or how can I give more knowledge so it can basically correct those errors? So those are something we're working on right now.
Well, Arindam Mitra, thanks for joining us today. And to our listeners, thanks for tuning in. If you want to read this paper, you can find a link at aka.ms/abstracts, or you can find a preprint on arXiv. See you next time on Abstracts.